Alright everybody, here we are at lesson 4, factoring completely. Before I begin with the actual lesson, there is a date that I want you to write down because this will be a mandatory, needs to be online for this date to be able to take the test over factoring, and that is Wednesday, April 15th, okay? So this is next week on Wednesday. Okay, you will be required to mandatory be online on Wednesday, April 15th. Alright, we will be taking our test online that day, meaning you're going to take it in front of me and your video will have to be on. So some of you don't always turn your video on. So on this day, your video will be on. I will discuss it more on Friday during our live session on Friday. Alright, so here we go. Factoring completely. What does it mean? Okay, factoring polynomials completely. I'm going to tell you, luckily, what's nice is nothing is new here. Everything is what we've learned already. We're just going to build on some skills here for the next 4 days of class and then a test on that Wednesday. Okay, so first, the very first thing we learned of factoring was to find the GCF. So it is very important that every question from here on out you look at, you first look for a greatest common factor. Okay? Sometimes you're going to take out a greatest common factor and that's all you can do. There's no further you can go. Alright? After you look at your greatest common factor, you're then going to look at the number of terms that are left. For example, if we have 4 terms, okay? 4 terms means, hey, I am set up that I can do grouping. Okay? Remember, the grouping method is just simple. I'm going to group 2 terms together, and I'm going to group 2 terms together and take out what they have in common. Okay? If there are not 4 terms, well, there is a possibility that there could be 3 terms. Okay? If there are 3 terms remaining, okay, this 3 terms is a trinomial. Okay? Now, trinomial means that I am going to find, hey, what multiplies to and what adds to. I'm going to make that Ma chart, and I'm going to try to factor it by finding what multiplies and adds. Now remember, trinomials, some of them could be x squared plus 3x plus 2. A trinomial could also be something like w squared plus 4wx plus 4x squared. That's a trinomial. Remember that a trinomial could also be something that is like x to the 4th minus 5x squared minus 36. Okay, that is also a trinomial. All of those fall under trinomial terms. Okay, now what if there's not 3 terms? What if there are only 2 terms left? Okay, if there are 2 terms left, what we are going to look for here is it a difference? Now remember, difference means minus, okay, of squares. Now just a reminder that difference of squares, that is if I have a squared minus b squared, remember that means I can go straight to this kind of factoring. What's the square root of a squared? Well, a. What's the square root of the b squared? B. And one has a plus and one has a minus. Okay, so none of today is new, but this here might help you out to do some of today's questions. So what I'm going to give you here is I'm going to give you an example. And then from that example, we're going to look first, is there a GCF? After we look for the GCF, we're going to look at the number of terms. Are there 4? Are there 3? Are there 2? And then we're going to figure out how to factor it. Once we figured out how to factor it, we're going to do a lot of pausing and playing today because we've worked through all of our ways of factoring up until this point. Alright, so here's the first example. I want you to write it down. And remember, the very first thing of factoring is there a GCF? So I want you to pause right here and see if these terms have a greatest common factor. These terms do have a greatest common factor of 9 a squared b And when you take out the 9a squared b, you are left with 3a plus 1. Now all I'm going to do here is I'm going to look on this inside. I have two terms. They are not a difference, and they are not perfect squares. So I am done. This here is the answer to that first question. Okay, here is the second question. R squared plus 16r plus 63. I want you to pause, see if there's a GCF. The answer is no, there is no GCF. So now I'm going to look, how many terms do I have? Well, I have 1, 2, 3 terms. Okay, so that tells me, hey, I am going to try to factor a trinomial, and I might need to make one of these. Alright, so I'm going to take, remember, a trinomial is your a times c, 1 times 63. So what multiplies to 63 and adds to 16? I want you to pause here and find your factors of 63 that and then add to 16. Alright, so those factors were 7 and 9. Okay, I replaced my 16 right now with the 7 and the 9. Remember, when you replace, it has to have the same term, so 7r plus 9r. Right at this point, you are ready to group them together and finish your factoring, so go ahead and pause and do so. Alright, so the final answer for this question is this one right here, that r plus 7 and that r plus 9. Okay, next question. Here we have our 2c squared minus 32d squared. I want you to pause and see if there's a GCF. If there is, take it out. Alright, indeed, there was a greatest common factor of 2 here. Okay, just because I took out the greatest common factor does not mean I'm done. I'm going to look here at my two terms, my c squared and my 16d squared. I have two terms, which means I'm looking for a difference of two squares. Well, when I look here, I have a minus sign. So that minus sign lets me know I do indeed have a difference. Now I'm going to look, do I have perfect squares? Well, c squared. Okay, c squared is a perfect square. 16 and d squared is also a perfect square. That means this factors one more time, and I must remember that I took a greatest common factor first, and it's going to come with me, and I'm going to factor this difference of squares. Okay, what is the square root of this first term? The c squared? Well, that's c. What is the square root of this second term over here? The 16d squared? That is 4d. And I have a plus and I have a minus. And this right here becomes my final answer to that question. I realize that this is another difference and another perfect square right there with the 4. But because the d is not a perfect square and neither is the c, this will not continue. Okay? Next question here. K squared minus 27kj minus 90j squared. What I want you to do first is I want you to see if there's a greatest common factor. Always look for that greatest common factor. If there is, take it out. If there's not, try to determine your method of factoring. Okay, there is not a greatest common factor, so I have that k squared minus 27kj minus 90j squared. It is 3 terms. So I'm going to try to find what multiplies and what adds. Okay, remember there's that 1 in front of k squared here. 1 times negative 90. And I'm adding to negative 27. I want you to pause and find your factors. Alright, those factors were negative 3 and 30. What's important here, it doesn't matter what order they go in, but what is important is that when you put the negative 3, it has a kj, and when you put the positive 30, it also has the k and the j. Order does not matter. Alright, go ahead and group these, and I want you to pause here, and I want you to finish factoring it out, because I know you can do this. Alright, here is that final answer right there, k minus 3j, plus, or times, k plus 30, and Mrs. Stair made a big old mistake, meaning that this should have a 30j on it. So, double check yourself that you have the j like I do there. Okay? Alright, a couple more, guys. I realize we're getting a little long here. Oop. So, I'll just leave them both. Okay? So, look at that first one on the top there. And I want you to first see if there's a GCF. If there is, take it out. Alright, so that first one indeed did have a greatest common factor. Now, when I look in here, I have 1, 2, 3, 4 terms. Okay, 4 terms means, hey, I want to try to use grouping. So I'm going to group these two together here, and I'm going to group these two together here. You may use brackets instead of parentheses right there if you want to, if it helps you. You don't have to. Just remember that that 2 is still indeed part of your answer. So go ahead and factor the inside there. I'll put it in brackets here on my next step, but go ahead and factor the inside there and get it down to your final answer. Alright, right here, this is what you should have as your final answer. Okay, that 2e squared plus f times g plus 2h. Now, if you did not take a greatest common factor out at the beginning, you are actually not completely factored because what will happen is one of these two groups that you may have had a 2 in common. Alright, there's that last question. I want you to try it out here on your own and see what happens. Alright, this one here is a trinomial question. There was no greatest common factor to start with. There were 3 terms. Okay, so I went ahead and found, hey, what am I multiplying to? What am I adding to? And I found those factors. Alright, and then I'm going to make sure when I input my factors in that my 4 and my negative 9 both have r squared on them. Alright, so now I'm going to group and go ahead and go from there and group and see what you get. Alright, here is as far as I made it so far. Now, I didn't circle it because we are not done. R squared plus 4, R squared minus 9. The reason why I say we are not done is because I'm going to look here. Hey, look, I have a perfect square and a perfect square. Oh, but that one has a plus in the middle, so I can't do any further. But this one here has a perfect square with a difference right there. So this r squared minus 9 will factor one more time. And I must remember that part of my answer is still r plus 4. Okay, so now that r squared minus 9, take the square root of both, and it doesn't matter the order. Now here is my final answer to that question, all the way down to the end. Alright, tomorrow we will have another live session, so Friday. I look forward to seeing you all. We'll work on more of this together. Alright, thank you.